In this video, we'll be focusing on a specific type of transformation called dilation. So a dilation is an operation which takes a pre-image and it changes the size of that image but keeps the shape. So in essence, it changes it to a similar figure. Alright, so a dilation will have a center of dilation, so that's the point of reference, and usually our center of dilation, and for this video, our center of dilation will just be the origin, which makes things a little bit easier. And it will have a scale factor, and what the scale factor does is it makes the image either bigger, so it enlarges it, or smaller, so it shrinks it. So now if our scale factor is more than 1, then our image will be bigger, and if our scale factor is less than 1, then our image will of course be smaller. So let's look at let's shrink this image. So let's say our scale factor is 0.5. So if our scale factor is 0.5, then the coordinate of every vertex will change to half of what it was before. So for example, the coordinates of h is 3, 2. That means the new image, let's call it h1, will be half of 3 is 1.5 and half of 2 is 1. So our new image will have a point at 1.5 comma 1 right here. Alright, so we can do the same thing for each and every one of our vertices. So E is at negative 3 comma 2. Oops, let's fix that up. Negative 3 comma 2. Which means that our new image will be at negative 1.5 comma 1. Just halving those coordinates there. So negative 1.5 comma 1 is right here. And again, we do the same thing for G. G is currently at 4 comma negative 2. So the new G will be at half of 4 is 2, half of negative 2 is negative 1. So it will be at 2 comma negative 1. And then we do the same thing over for F, and we get that it should be at negative 2, negative 1. And so our new figure, or new image, will look like this. So as you can see here, the figure is similar. It has the same shape, it's just a different size. It's actually exactly half the size. Now, one thing about the center of dilation that we spoke about before, if you take that point, you can actually join the vertex, the old vertex and the new vertex. Not sure what's the use of that, but it's just so you know, that point is really a connection, like it's like a center that shows you how that image was enlarged. Alright, let's look at another one, and this time let's make the figure bigger. Okay, so this time I'd like our scale factor to be equal to 1.5. This means that our image that we get from this pre-image is going to be larger. So that's one difference between this example and the last example. Another interesting difference here is the fact that the diagram before was centered around the origin, when this is totally not on the origin. But that's completely fine. We can still have our center of dilation at the origin. So now, instead of the figure being entirely, one figure being entirely within another figure, it will have a somewhat interesting look. So let's go ahead and see what our image looks like after we enlarge it with this scale factor. And so we just again multiply each and every coordinate by 1.5. So the coordinates of A is 2 and 8. So A prime will be, let's say, 2 times 1.5 is 3. And 8 times 1.5 is 12. So our new A will be at 3 comma 12. And excuse the funky looking coordinate plane here. I had to extend it to make it larger so it would fit. Alright, so that is where our new A will be. So let's label that A prime. Alright, and we do the same thing for B. B prime is 3 because that's 1.5 times 2 here. and 1.5 times 5 is 7.5. So our new B is at 3, comma 7.5. So that is up here. Now we do the same for D. So D, 1.5 times 8 is 12, and 1.5 times 10 is 15. So we have 12, which is over here, and going up to 15, which is all the way up here, which is why I had to extend my coordinate plane. But our D prime is up here, and our C prime, which our C is 6, 1.5 times 6 is 9, comma 1.5 times 5, we already know, is 7.5. So we have 9 with 7.5, which is right here. Alright, so our new image is here, joined up to D. That's a terrible line. I'm going to try and fix that. There we go. And so now, as you can hopefully see, I know it's a little bit messy, I'll clean it up a bit. So as you can hopefully see, the image is the same shape. They're actually similar images, but they're different sizes. Our red image here is 1.5 times the size of this. And remember, we used our center of dilation as this. So if you did want to see if that is actually a correct mapping, we could use the center of dilation and join point A to its other, the new point A, join point B to the new point B. You would be working with a ruler. I am obviously not. Join point C to the new point C, and same with D. There we go. So we know from that that our mapping is correct. If even a little messy, it is correct.